Hello and welcome, ladies and gentlemen. We are back. We are looking at activity 3.5 this evening, constructing and inscribing an equilateral triangle. It says, in this activity, you will construct an equilateral triangle. To perform the construction, you will need only a compass and straight edge and rely on the basic geometric constructions you have learned, such as duplicating a line segment. So number one here, again, I apologize that this is so light. My next packet will be better, but if you are following along with your packet, that'll be okay. So here we go. Sophie claims that she can construct an equilateral triangle by constructing and then duplicating a line segment 3 times and having the endpoints of all 3 line segments intersect. Roberto thinks that Sophie's statement will not result in an equilateral triangle. Is Sophie correct? Explain why Sophie's reasoning or Roberto's reasoning is incorrect. So I would say, thinking about this, I would say yes. I would say yes, because it says, is Sophie correct? The answer would be yes. And then explain why. So imagine you make one line segment, okay? And then you go ahead and you duplicate that line segment. And you duplicate that line segment. But instead of just duplicating them like this, 1, 2, 3, okay? We're imagining these are all congruent. You duplicate one, and then when you duplicate the other, you put it right here, and then when you duplicate the third, you put it right there. And all of your endpoints are intersecting, right? This is like creating vertices, right? So I'm not sure what Roberto was thinking, what his confusion was on this one, but I would say that Sophie is definitely correct. If you have one line segment and then you duplicate it 2 more times to have 3 perfectly congruent line segments, then I would say yes, for sure, you would create an equilateral triangle. I would say maybe Roberto's mistake was that assuming that just because you have 3 lines that are congruent doesn't necessarily mean that you would have all equal angles as well. Because imagine if you had 4, so imagine you had one line and you duplicated it 3 times, so you had 4 lines that were congruent. Just because you have 4 lines that are congruent doesn't mean that you make a square, right? So maybe he was thinking something about how just because you have congruent lines and you put them together doesn't necessarily mean that you're creating a triangle. But a triangle is a special geometric shape for the fact that the number of angles that are congruent and the number of sides that are congruent will always match, right? Because in a scalene triangle, you won't have any angles that are matched up. In an isosceles triangle, you'll always have 2 angles that are matched up. And in an equilateral triangle where all 3 sides are equal, you will have 3 angles that match up, which isn't the case for, like a quadrilateral where, like this rhombus, where these opposite ones are congruent and these top and bottom ones are congruent. But there you go. I would say that was probably Roberto's confusion. So 2 here, we have construct an equilateral triangle using the given side length, then describe the steps you performed for the construction. So I would say, this is very similar to the first, I think it was one of the first activities we did here. And in that activity, I told you that constructing a line segment that's, okay, so here's what it was. Here, sorry, real fast. Trip back in time. Memory lane. We had our radius like this, and it said duplicate it so that this was A and this was B. It said make line BC so that C touches the circle, and all we did was we constructed an arc, and then where those intersected, we made that AB, or BC I mean, and then we connected that one. So similarly, okay, imagine, so I need to find a point out here in space somewhere, okay, if I had to guess right about where the tip of my pin is, okay, where I'm going to connect 2 lines that are congruent to this line. So what I'm first going to do is I'm going to use my compass, and I'm going to go ahead, put my point on one end of this line segment, and then put the compass, okay, and then make it as wide as this line. So now, right now, my compass is the same length as this line. So I can duplicate it however I want. So what I'm going to do, though, instead of just trying to guess, right, instead of just guessing and doing some crazy stuff, what I'm going to do, because I know that the 2 lines that I'm creating will intersect, I'm just going to make one arc like this, and then I'm going to flip this over, and then make another arc, and where these intersect this should be that point that I was talking about out in space here, where now all I need to do is connect this point with this point and this point with this point, and I will have created an equilateral triangle. Excuse me while I grab my straight edge. Okay, so the reason that this works, so when we construct an arc, what we're doing is we made this the radius of our circle that we would be constructing with our compass, right? Because compasses make circles. And so by making this, making our compass this length here, we made this so this was the radius of our circle. So by making this point the center of my circle, which is what you do when you put the point of your compass somewhere, and creating an arc, I'm making one circle that goes here, and then by doing this the other way, I've made it so that I create an intersection with two line segments that'll be congruent to this one, because this is one length, and then I've made my compass equal to that length, and then by connecting here and here, and then by connecting here and here, I've constructed an equilateral triangle. I don't know if that was the best explanation ever, but I hope you guys can kind of see how that would work. You're basically just duplicating the line, because you know, so if you're trying to duplicate it with a square, it'd be a little harder, because with only one line, you'd have to create a 90-degree angle, and then you'd have to do some more stuff. But with this triangle, all you need to do is just create two arcs there. Okay, so there you go. And then describe the steps you performed for the construction. You can say set compass to length of given line, and then made one arc. So you made, and then this is where, so you made one arc with point of compass on A, and then you can label these. Made one arc with point of compass on B, right? And then connected, so then my last thing, and I'll do it over here, connected A and then B to intersection created by the two arcs. So if you wanted to write this much, you are more than welcome to. This is because, remember, this is like the total breakdown, step by step, exactly what I did. I set the compass to the length of this. I made one arc with a point on A, that was this arc. And then I made one arc with a point on B, that was this arc. And then I connected A and then B to this intersection created by the two arcs, which was right there. Okay, so there you go. So you can go in this in depth if you want. If you did a different process, obviously this would look different for you. But regardless, you would want to put all of your steps here. So maybe if you wanted to skip this step about setting the compass, you wouldn't necessarily need to put that, but you would still want to say how you constructed your arcs, why you constructed them, right? And then go on from there. So there you go. So that was number 2. Now I'm looking at number 3 here. And let's go ahead and get this, there we go, get this centered up. All inscribed equilateral triangle, or an inscribed equilateral triangle in an equilateral triangle is an equilateral triangle inside a circle with all of its vertices touching the circle. There we go. That was a struggle. So number 3 says show 2 different ways to construct an inscribed equilateral triangle using each given circle. Explain your process for each construction. So for this one, they give us a little hint over here. They say, how can you use the process for constructing an inscribed regular hexagon to inscribe an equilateral triangle? So I would say that this is helpful for us because they've shown us 2 different ways to construct an equilateral hexagon inside of a circle at this point. So well, first thing I'm going to do is I'm going to make a radius for both of these. Okay, and you can't see this other one quite yet. I guess I'll do all of one circle first and then do the next circle. So here we go. So for circle P, I've constructed this radius. The first one that I'm going to do is I'm going to, just like we did a second ago, I'm going to construct an equilateral triangle, and I'm going to go up as well as down. Whoop, there we go. I'm going to go up as well as down because in order to make an equilateral triangle, I need all 60-degree angles. Well, an inscribed equilateral triangle has 60-degree angles that go from one point. So this is going to be one point of my triangle to another point, to another point, to another point, right? So if I make the hexagon, so that if you'll remember, one way that we made our hexagon was that we connected. So I'm going to go ahead and just make these intersections a little easier to see. So one way that we created a hexagon was by making all of these triangles. That's one way that you can do it. Okay, and this is also one way we can make a triangle. So So this angle, okay, so this was 60, this was 60, right? And so together they were 120. So if this is going to be the point of my triangle, I need it to be just 60 instead of 120. Well, we know how to bisect an angle, right? So I can go ahead and do that. I'm going to make this arc a little smaller. Oops. And then I'm using the skill we just learned a minute ago to bisect an angle. Okay, so, oh, and I'm trying to think best way to do this. So, and so actually the best way that you want to do this, so if I just were to bisect this 120 degree angle, we would just end up drawing this line again, the radius, because we already know that this line cuts it in half. But what I need to do is I need to create a 60 degree angle from this point down this way and down this way. So what I can do to turn this 120 degree angle into 60 is I can turn this 60 into 30 and turn this 60 into 30. So then 30 and 30 would give me my 60. So I'm bisecting both of these separately. Okay, so I'm just going to go ahead and do a little bit of that action, and that was bad. My compass adjusted on me, so I'm going to redraw that one. Okay, so that first line, like I said, compass kind of adjusted on me, so that one we won't look at that one. Okay. Wow, I'm struggling. Here we go, let's try this again. There we go. Okay, and then so now, and again, this is just what we learned how to do, just a 3.5, I believe, section 3.5. So now I'm going to draw a line that goes through that point and goes to my circle here. Because I'm drawing an inscribed triangle, so I know that it's going to have to go, all of its vertices, all of its points on the triangle are going to have to touch the circle. So far, this would be 1, this will be A, we'll say this will be B. Okay, and so now I need to bisect this angle. Okay, you can see, so now I want to draw through this intersection. I apologize about the shadows here. You guys won't be able to see it super great. Okay, and then this would be C. And so once I've done this, so now I know that this angle, this one right here, is 60 degrees total because I had 120 total, but then I halved this 60 and I halved this 60, so now I have 30 and 30, which is 60. And so now the last part's easy. I can just connect these two lines. Boop. And now we have an equilateral triangle that's inscribed in the circle. So that's one way that you can do it. Okay, is by creating these triangles. And so if you wanted to, so this first exercise we did was creating triangles, right? And so that's what I did. I just created these triangles. I left off these sides because you don't end up needing them. But you could construct these triangles and then bisect these angles. Okay. Welcome back, ladies and gentlemen. I have, my iPad told me my storage was full once again. So I had to cut the last video. I'm going to combine it with this one. This one's going to be really short because it cut me off on the last part of the last problem here in section 3.5. So we are constructing an equilateral triangle. You know all that if it's connected to the other video we've made. So what I've done is I've drawn a radius. I've duplicated the length of the radius with my compass. I put the point of my compass on the part of the radius that touches the circle. I created one arc. I then put the point of my compass at that intersection, created a second arc, and I'm going to do that. Wow, this is super out of focus. There we go. And I'm going to do that 4 more times here. Okay, so there's 1 and 2, 3, and 4. And my compass looks like it was a little off. For the sake of you know, just it's okay to be wrong sometimes. That is the world we live in. You know, if you're going to be a brain surgeon, hopefully you're not wrong that often. But you know, it happens. So here we are, looking frantically for my straight edge. I got all flustered when my iPad told me I was out of storage, and apparently threw it across the room or something. Here we go. All right. So they asked us so to make a equilateral triangle. So I'm going to go ahead and connect every other intersection here. The reason I'm doing every other is because instead of making a hexagon with 6 sides, I want to make a triangle with just 3 sides. And apparently I cannot use my straight edge either. very flustered. Here we go. But this is the process that you would do. So same as activity, I believe it was 3.2, asked you to construct 3.2 asked you to construct a hexagon in this way. If you do that same process, and then instead of connecting every single one of these intersections, you just connected every other, you would create an equilateral triangle. And so by drawing this radius and having my first point start there, hopefully yours would have its point here. Like I said, I had a little bit of human error here, so I have this, and it does kind of look like maybe it's a little bit of a squatty triangle instead of a perfectly equilateral one. You can see my one up here is much better. But you know, if you understand what the process is here, okay, you make a radius, you set your compass equal to that radius, you go around the circle 6 times, okay, and then you connect every other intersection that you've done by doing that, then you will be good to go. Yeah, and then how this turns out will just kind of depend on that, right? So hope you guys have a wonderful evening. Thank you for bearing with me for these 2.5 minutes of extra video that you guys get after the iPad storage. I will get it figured out so this does not happen again. Hope you have a good one. Adios.